Hi guys, welcome to another lecture on the number conversion. So this time our aim is to do binary to hexadecimal. Again, the process is very easy. So I have taken a very big binary number. So if you remember in octal, right? In octal we used to have like 3-bit grouping. So we were dividing into groups of 3. Now if you closely observe this particular table, oh, if you closely observe this table, so you can see that, for example, the binary equivalent of the hexa stuff, right? So they are basically 4-bit, right? Because hexadecimal has actually 16 alphanumeric digits, right? From 0 to 9 is 10 digits, and A, B, C, D, E, F are 6, right? So 10 plus 6, 16. So basically, hexa has 16 digits. So in terms of boxes, right? I will require 4 boxes. Why? Because log to the base 2 of 16. 2, why? Because we are doing binary is equal to 4. So I require 4 boxes to represent the hexadecimal digits. For octal, in the last case, it had 8 digits, so we required 3 boxes. So now you see we have a very huge number upside. So we have 1. Again, I'm writing. This is 1, 1, 1, 1, 0, 1, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 0. Now, since for our case of hexadecimal, we require 4 bits. So now instead of 3, like in the case of octal, we will actually group this into a group of 4. So we begin from the LSB, right? Least significant, the last digit. Begin from LSB. Fine. So these are the 4 groups. Now again, a new color for the next group. Right. So this is the group number 2. Again, let us change the pen color just for easier visualization. This is another group of 4 binary numbers and another group of 4 binary numbers. Finally, I have the last group having only a single number, but for representational, I will just show adding 3 zeros, right? As I already said, adding zeros before a number makes no difference to the number. 1, 0, 1, 0, 0, 1, 2, 0, 2, 0, 0, 0, 2 are all same. Now write the hexa equivalent from the master sheet that is on the screen. So this is our master sheet, right? So you can see we can then you can write from anywhere, but okay, we begin from the right hand side. 0, 0, 1, 0, right? Let me just draw again. So 0, 0, 1, 0 is in binary is hexadecimal 2. So this is 2. Then we have 0, 1, 0, 1, right? So 0, 1, 0, 1 is hexadecimal 5, right? So this becomes hexadecimal 5. Then we have 0, 1, 1. So 0, 1, 1 is hexadecimal 7. 7 is easy to remember, all ones. Then we have 4 ones. 4 ones is also easier to remember. It is character F, right? So this is F. And finally 0, 0, 0, 1 is actually 1 itself. So basically this number, right? This number completely, which is binary base 2, is equivalent to this number, which in hex is 16. Right? I hope this was easy. So just group into group of 4s and beginning from the right hand side and write their hexadecimal equivalent. So it is usually good to have this table entirely in your mind, right? So this helps you for easier conversions. Guys, so that's it for this video. Thank you for